Okay, now it's time to answer these other questions. From our graph, let's determine the domain and range of G. So domain is the set of x values that are on the graph. So if I imagine projecting things down to the x-axis, I'm going to have x values that range from -9 all the way over up to and including +1. So the domain is -9 to +1. How about the range? If I look at the range, I imagine trying to determine the y values that are on this graph. And so if I imagine pushing things over to the y-axis, I'm going to get everything from 0 up to and including 3. So the range then is going to be everything from 0 to 3 inclusive. List the intervals over which G is increasing and the intervals over which G is decreasing. Well, as I move from left to right, I'm heading downhill. That means the y values are getting smaller. That means the function is decreasing. And that happens from the x value -9 up to the x value -3. So that would be where it's decreasing. And then starting at the x value -3 over to the x value 1, I'm heading uphill. So that's where it's increasing. As far as relative extrema go, or local maximums and minimums, local extrema, I look at these points, and the point -3, if I look around -3, the y values are either equal to 0 or above 0. That means I have a local minimum here. So I have a local minimum at -3. Remember, the points -9, 3, and 1, 2 don't qualify as local maximums or minimums because there's no graph on one side of these things. What about the point -7, 1? Well, if I look to the left of -7, 1, I've got the y values are bigger than it, and to the right of it, the y values are smaller than it. So this really isn't a local maximum. It's not a local minimum. It is a key point on the graph, however, and helped me graph it. But the point that it corresponded to was the point 42, and this is neither a relative maximum or relative minimum either. Okay, so that's a discussion on domain, range, increasing, decreasing, local maxes, local mins, for the graph y equals g of x. So that'll do it then for checkpoint quiz 1.8. Okay, number 2, we're given a function f of x equals x squared, and we're asked to find a formula for a function g whose graph is obtained from the graph of y equals f of x after the following sequence of transformations. So here we have 1, 2, 3, 4, 5 transformations. We want to build a formula up that will be the result of these 5 transformations. So the first transformation we're asked to do is to shift left 3 units. Okay, so f1 of x, this will be the result of the first transformation. Shifting to the left 3 units indicates we're changing the x values. So we're going to be looking at changing the input x here. So I'm working inside the function. And to shift left, I'm going to replace x with x plus 3, because you always do the opposite. And so f of the quantity x plus 3 would be the quantity x plus 3 squared. 2. We want to reflect across the y-axis. So how do we do that? Well, reflecting across the y-axis, once again we're modifying the x coordinates. We're going to replace x with their opposites. So in the formula for f1, I'm replacing x with its opposite, and I follow that through. And here's the formula for f1. I replace x with its opposite. Next on the list, I need to shift down 1 unit. Shifting down 1 unit means I'm subtracting 1 from the y values of the graph before it. And so how do we do that? We shift 1, or excuse me, we subtract 1 from the outputs of the previous function. So I'm subtracting 1 outside the function. And the formula we had for f2 of x was the opposite of x plus 3, quantity squared, and then we subtract the 1. Step 4. We're asked to do a vertical scaling by a factor of 2. That means we're going to be multiplying all the y values in the previous graph by 2. So I'm going to be multiplying outside the function by 2. And so this is 2 times this expression, like that. And finally, I want to reflect across the x-axis. That means I'm going to be taking all the y values in step 4 and taking their opposite. So f5 of x would be minus f4 of x, which would be then a minus 2 times all this. All right. So our function g of x is negative 2 times the quantity, the opposite of x, plus 3 squared minus 1, which we can go ahead and simplify. It's negative 2 times the quantity, the opposite of x plus 3, quantity squared, plus 2. So it's negative 2 times, multiply this out, I get the opposite of x squared, which is x squared, minus 6x plus 9, quantity squared, plus 2, which will be negative 2x squared, plus 12x. Oops, this I took care of the square already. Minus 18 plus 2. And so I get from my final answer, g of x, negative 2x squared plus 12x minus 16. Now something that's instructive to do is to actually start with y equals x squared and graph each of these intermediate phases to actually see the transformations taking effect. And so in the calculator here, what I've done is I've started with y equals x squared, and then I've got each successive function. So let's go ahead and take a look at this. There's y equals x squared. And here's y equals x plus 3 quantity squared. So you can see I've moved it 1, 2, 3 units to the left, like I was supposed to. So now I'll remove this from the window, and now I'll go to the next one. And I've replaced x with its opposite, and that should reflect the thing across the y-axis. Let's see if that's what happens. So there's the original, and sure enough, you can see it's a reflection across the y-axis. So now I'll take this one away. And the next thing we were supposed to do was to shift the graph down 1 unit. So we subtracted the 1 there from the outside of the function. And let's see that play out. So here's my original graph, and then look, the next one I've dipped down 1 unit. So I've just moved it down 1 unit. So now I'll take this one off. And the next transformation, I wanted a vertical scaling by a factor of 2. So let's see what that looks like. The original graph, and I've multiplied all the y coordinates by 2. So this point here was at 3, negative 1. It's now down at 3, negative 2. And the result is I've made it skinnier. So once again, if you imagine taking silly putty and putting it over the graph and then stretching it away from the x-axis, you're going to get this narrower graph. And then the last transformation we were asked to do was to reflect it across the x-axis. And so we multiplied everything by a negative 1. And let's look at that. There it is. And I just flipped it across the x-axis, and you can see that happening. All right, so that'll do it then for Checkpoint Quiz 1.8.